Example 4. We have e to the x plus y times dx plus 2 plus x plus y e to the y times dy equals 0 with the initial condition y at 0 equals 1. We can see m is e to the x plus y and the n is 2 plus x plus y times e to the y. Check whether this is an exact equation or not by finding the partial derivative of the m with respect to y gives us 1, and partial derivative of the n with respect to x, which is also 1. So this is another exact equation. Next, we are going to find the solution. For our m, which is e to the x plus y, as m is the partial derivative of the solution with respect to x, and n as 2 plus x plus y times e to the y, or it is the partial derivative of the solution with respect to y. I will work on the m. So fxy, or the solution, is obtained by integrating the m e to the x plus y with respect to x, and then added by the function in terms of y as a constant of integration. So our solution fxy is e to the x plus x times y plus the g of y. And then use the n by equating n with the partial derivative of the solution that we just got with respect to y. And the n is 2 plus x plus y times e to the y. The partial derivative of the solution e to the x plus xy plus g at y with respect to y will give us the first term will be 0, the second term will be x, the last term will be g prime at y equals the expression of the n, which is 2 plus x plus y times e to the y. So you can see that 2 plus y e to the y is the g prime of y. Next, we're going to find g of y, which is the integral of 2 plus y e to the y with respect to y. Integral of 2 with respect to y gives us 2y. The integral of the y e to the y with respect to y, again, we can use by parts as we check with the liaise, L-I-A-T-E. The y is the algebraic function. The e to the y is the exponential. So y as algebraic is the polynomial function. It's going to be the u, and e to the y dy as the dv. Since the u is a polynomial function, we use a tabular by parts. The first column, we find the derivative. Second column, we find the antiderivative. Since the u is the y, the dv is e to the y. We find the derivative of the first column all the way to get 0. So we get 1, and then the next we get 0. The second column find the antiderivative, and then form the product. The first product has plus sign in the front. The second product has negative sign in the front. Then we get g of y as 2y plus the product of y e to the y minus the product of the 1 and e to the y. Now we're gonna find the c. Okay. From the general solution, which is fxy equals c, and our fxy is in the form of e to the x plus x times y plus 2y plus y e to the y minus e to the y equals c. To find c using the initial condition, or y at 0 equals 1, that means x equals 0 gives you y equals 1. So e to the 0, which is 1, plus 0 times 1, we get 0, plus 2 times 1, which is 2, plus 1 times e to the y, or e to the first, and then minus e to the first equals c. E to the first cancel, gives us c equals 3. That means we get the solution of the initial value problem is e to the x plus xy plus 2y plus y e to the y minus e to the y equals 3.